Okay, so 3.2 is about the synthetic division algorithm. So for polynomials, quotients and remainders, f of x and g of x are polynomials with g of x lesser degree than f of x, with both f of x and g of x being degree 1 or greater. There exist unique polynomials q of x, the quotient, and r of x, the remainder, such that f of x equals g of x times q of x plus r of x. All they're really saying is that for f of x and g of x, when you divide them, there's a quotient and a remainder, such that between when all the polynomials are multiplied, your answer times your quotient plus your remainder is equal to the original function, and your remainder is either 0 or a lesser degree of g of x. That's just saying that when you divide this by long division, you can get 3x cubed minus 2x squared to minus 150 over x squared minus 4 is 3x minus 2 plus 12x minus 158 over x squared minus 4. Now, it's not because we just straight divide that, but use your normal division algorithm to do it. However, there's arguably an easier way called synthetic division. So for instance, synthetic division, it only works when dividing by linears and ideally if it's x plus or minus something. We can get around that if it's like 3x minus 5, but we're going to have to take some precautions, and we'll talk about that when we cross that road. But you take the solution to your denominator, so that what makes us 0, 4, to the equation set equal to 0, and your coefficients, you bring them down. 3, negative 2. There's a 0x here. You have to include all of your missing terms, just like if you're doing long division. Here's how the algorithm works. You bring down the first term. You multiply what's at the bottom by the outside to go up. So the 3 times the outside 4 is 12. Add going down to get 10. 10 times 4 is 40. Add going down. 40 times 4 is 160, and then add going down. So generally speaking, you add going down, and you multiply going up. And what does this relate to? Well, let's look at our first term here. 3x cubed divided by x. We're expecting our first term to be an x squared term. So this should be 3x squared plus 10x plus 40 is our constant. So what is our 10? This is our remainder. It goes over whatever you're dividing by at first. Remember that if you did 71 divided by 5 with your old school division style, you'd 5 into 71, you get 1 minus 5. You get 21. 5 into 21 4 times, minus 20. Get a remainder of 1, and you would put it over the 5. So similarly, if we were dividing, we put it over whatever we were originally dividing by. So this is plus 10 over x minus 4. So this is the normal way we would do f of x over g of x. Now they may ask us to find the quotient and the remainder, where f of x is equal to that form up there, g of x times q of x plus r of x. If they ask you for this, your g of x is the x minus 4, which you divided by. Your q of x is the portion of your answer without the remainder. And your r of x is the remainder without the division, so the plus 10 from there. How do you get from here to here? Remember, g of x is x minus 4, so if I multiplied x minus 4 to the other side, it would get distributed to everything. So that means x minus 4 times this whole solution here. But the x minus 4 for the right side would actually cancel, so that only the 10 would be left. So let's just practice dividing using the algorithm. 5x cubed minus 6x squared minus 28x minus 2 over x plus 2. So since it's x plus 2, negative 2 goes outside. 5, negative 6, negative 28, negative 2. 5 comes down. 5 times negative 2 is negative 10. You add going down to get negative 16. Negative 16 times negative 2 is 32. Add going down, you get 4. 4 times negative 2 is negative 8. Negative 2 plus negative 8 is negative 10. So that means your solution here when dividing is 5x squared minus 16x plus 4. And then the negative 10 over x plus 2, so minus 10 over x plus 2. And that's really the only way the algorithm works. Now, if something has a remainder of 0, then it's a factor, and we'll talk more about that possibly in the next video, but let's continue. Here, negative 1 goes on the outside. 1, 3, 11, 9. 1 comes down. 1 times negative 1 is negative 1. 3 plus negative 1, 2. 2 times negative 1, negative 2. 11 plus negative 2, 9. 9 times negative 1 is negative 9, 0, which means you have a remainder of 0. So my solution here is x squared plus 2x plus 9 with no remainder. Now technically we can do this with fractions as well, whether you like it or not. 1/3, negative 2/9, 2/27, negative 1/81. 1/3 comes down. 1/3 times 1/3 is 1/9. At least these have a common denominator. Negative 2/9 times 1/9 is negative, or plus 1/9 is negative 1/9. Times 1/3 is negative 1/27. Again, common denominator is already there, so it's 1/27. 1/27 times 1/3 is 1/81. So this is 0. So my solution here is 1/3 x squared minus 1/9 x plus 1/27. So now we'll practice doing it in that other form that we talked about on the front page. Express the following functions in the form x minus k times q of x plus r of x for the given k. So this is when you're going to use the other form, not dividing, but you'll write it in what you divide by form times your answer plus your remainder. So when it says for f of x equals 4x to the fourth plus 5x cubed minus 13x squared plus 17 for k equals negative 1, they're telling you that the negative 1 is going on the outside. You still need to bring your terms down here. 4, 5, negative 13. Remember a 0 for the missing x term, and then 17. But otherwise, same strategy for solving these. 4 comes down. 4 times negative 1 is negative 4. 5 plus negative 4 is 1. 1 times negative 1 is negative 1. Negative 13 plus negative 1 is negative 14. Negative 14 times negative 1, 14. 0 plus 14 is 14. 14 times negative 1 is negative 14. 17 plus negative 14 is 3. Okay, so this time it wants you to express your answer in this form. F of x equals, this is now x plus 1, because x minus negative 1 is x plus 1, times your answer here, except for the remainder. So 4x cubed plus x squared minus 14x plus 14, and that whole thing is plus your remainder. And we will continue in the next video.